we studied the Barrister method. Actually, our target was to find the root of the equation by using our techniques. So it's also a technique to find the roots of the equation. If we consider this equation, we already studied this equation in previous class. This is five order equation. So there will be five roots that we can find from this function. How can we determine these five roots by using our numerical technique? This is our target. So we studied the Barrister method in previous class. Actually, the method was, first of all, we have to consider root at the initial stage, and then we have to divide the polynomial by a factor, and after that we have to check the root. If there is no remainder, we will declare the root of the equation that we already guessed. If if the root, if we get any reminder, then we have to go ahead according to Barrister method. That means we have to divide by a factor that is not x minus t, but it will be x square minus rx minus s. Someone is talking. Could you please? Or I can stop all. The sound is clear. Could you please, anyone, can you respond, please?
Yes, sir. We can hear you clearly.
Okay. So I just uh, repeating the previous class. So in previous class we did this. We studied already how a root is determined by using Barrister method when the equation is a polynomial. It's maybe fourth order, fifth order, fifth order, or more. So up to last, we said if we can determine these two equation, and after solving these two equation, we have to declare the root. Provided that we have to check the approximate error, how the percentage of error. If this percentage of error is within the limit, then we can stop the iteration. Otherwise, we have to iterate it again. To this, we already studied x equal to r plus minus root over of r square plus 4s divided by 2. After this, if when we will get x, that means the equation 7.39 from the book of Chapra. At this point, three possibilities exist. First of all, the result will be a third order polynomial or greater, not less than. In this case, Barrister method would be applied to the result to evaluate the new value of R and S. Another possibility, the result will be a quadratic equation, quadratic. In this case, remaining root could be evaluated directly by using the equation x. And last possibilities, it will be a first order polynomial. For this case, the remaining single roots can be evaluated simply using x equal to s by minus of x s by r. So in this class, our target is to solve a problem by using Baristol method. This is a problem, example 7.3. I recommend you to solve after this class. It is, you can take help from the book. That is why I am not discussing about this problem, but I am going to solve another problem from other source. So I am closing, just I am showing you the book that we already referred it to you. This book, you can check how this method is applying to solve the problem, how the root is determining here by following Baristol method. Example 7.3. So I will share another document. In this document, again, the steps of Baristol method. General step, first initial polynomial, it will be given. The initial guess, already we discussed in previous class, the factor including r and s, we have to divide by this factor will be x square plus rx plus s. That means we have to consider the value of r and s. If we consider r and s, then we can write this equation, second order equation, x square plus rx plus s. And then we have to use the recurrence relationship to determine the value of equation 2 that we already wrote in our previous class. That means the coefficient of the equation after division. So we already know the recurrence relationship between these two equations. Bn minus 1 equal to an, Bn minus 2 will be equal to an minus 1, and Bi equal to Ai minus Rbi plus 1 minus S multiplying of Bi plus 2, where I equal to n minus 1, n minus 2, 0. For recurrence relationship, from recurrence relationship, we can determine the value of B when we have value of I. This 2 was the very short. In short, we can say these two. These two equation we already used this recurrence formula in our previous class. So we have to follow these equations to solve the problem. If this is the problem, x to the power 4 minus 3x cube plus 3x square minus 3x plus 2. Where is the? I should take. Right, yes. So this is our target equation, provided that we have two initial value of r equal to 0.1 and s equal to 0.1, both are same. That means most of the time it will be given. That means always it will be given the initial guess. So this is our target equation, and for this, from this equation, we have to determine the rules. So initial guess is given here. From this equation, if we consider this equation is equation number 1, then a4 equal to 1. Very simply, we can determine from here a3 equal to minus 3, a2 equal to 3, a1 equal to minus 3, and a0 equal to 2. So first iteration. Then I go. First iteration, using recurrence formula, recurrence relationship, we can determine the value of B4. We know from previous classes that AN equal to BN. That is why we can write B4 equal to 1. Again, B3 equal to A3 plus RB4. That means it was Bn minus 1 equal to An minus 1 plus R of A, Rbn. It was the recurrence relationship. So we can write, so why it is not going down, and I check. Okay. So again, I have to split out for me. So using recurrence relationship, we can easily determine the value of B3, B2, B1, and B0. This is the key point of this technique to apply. If we can apply these rules, this relationship to determine the coefficient of the next equation, our problem will be mostly solved. So if this is the value of B's, at the same time we can also determine the value of C from value of B, because we know the recurrence relationship. Mostly both are same, but little bit change in most probably C3 and C2. So again, we can solve this problem. That means we can determine the value of C4, C3, C2, and C1. The result will be this. So our from the previous class experience, we can write this equation: C2 delta R plus C3 delta is equal to minus B1, and C1 delta R plus C2 delta is equal to minus B0. We have all the values like C2, C3, and minus B1, C1, C2, and B0. So when we have all these values, here it shows other like Cramer's rules. We don't need to go for Cramer's rule. Directly by using our calculator, we can determine the two unknown value, because two equation and two unknown value very easily we can apply to solve this problem by using calculator. Easily we will get the value delta R and delta S. So directly let's go to this point. We find the value of delta R and delta S. So when we will get the delta R and delta S, from previous class, again we can say we have to check the approximate error, because we already consider the initial value of R and S, and now we get delta R, delta S. So we can finalize the value of R by using the relationship R equal to R plus delta R, S equal to S plus delta S. So if we check, R become minus 1.4228 and S is minus 2.407. But our initial value was only 0.1, but the new value became minus 1.4228. So if we try to find the approximate error, it's become 107 point something. That means more than 100% is error. and at the same time more than 100% for the value of S. So this percentage of error is very high. So very simply we have to reject this value. That means this is not correct. We cannot stop our iteration. That means we have to search new value of R and S. This after it first iteration, this value is not correct. Again, from iteration 2, we have new value of R and S. This is the new value. R equal to minus 1.4228 and S equal to minus 2.405. Using these two, now our value of S and R already changed. With this changed value of R and S, again we should apply the recurrence relationship for finding the value of B's, means B4, B3, B2, B1, B0. This is the relation that we already applied in previous section, first iteration. So value of B and value of C, if we can determine, again we can say this is the two equation, C2 delta plus C3 delta is equal to minus B1, C1 delta plus C2 delta is equal to minus B0. So if all the values like C, C2, C3 and B1, C1, C2 and B0 are given from using our calculator, we can very easily find the value of delta R and delta S. From this equation, the delta R and delta S is defined here. It will be 0.7473. We don't need to follow this section. Please remember this. Grammar rule we don't need. We'll directly apply to calculator and it will give us these two results, delta R and delta S. Already changed the value. Drastic change we get. But still, we have to check if it is within the limit or not. So delta R and delta S. So our new value, previously we finalized the value of delta R and delta S minus 1.4228. Now we get delta R 0.7473. So our value become minus 0.6756 and S become this minus 1.1388. If we check the approximate error, again we get the percentage error more than 100. So again we have to go for next iteration. So our target is to follow the technique. How this technique is proceeding for to find the root of the equation. So value of R and S we have to determine. So with from these two iteration, we understand we can determine the value of delta R and delta S, and then we can finalize the value of R and S. After that, we have to check the percentage error. If the percentage error is more than the given value, we have to go for next iteration. So, of course, I will open the floor for your question. So, again, I am just summarizing. We have to follow the recurrence relationship. So, you have to, you can study more recurrence relationship. I already checked in internet recurrence relationship. You will get some help from there. how the two successive equations uh, can be make a tie by using recurrence relationship, how we can get the coefficient of the next equation from the previous value by using recurrence relationship. So if you can apply only this relationship, rest are very easy to calculate the value of R and S from the value of delta R and delta S. So this is the technique of this uh, method, that means Baristo method, to solve the root of the equation, to find the root of the equations. So up to this, now I am opening the floor for your question. We can discuss. Please.
স্যার আমরা যত বেশি ইটারেশন করব পার্সেন্টেজ অফ বিরোধ তত কমার কথা না, কিন্তু এই ক্ষেত্রে স্যার এই ম্যাথটাই দেখলাম স্যার যখন আপনি
No, no.
ইটারেশন করছেন।
Yeah, yes. No. This is not mandatory that the percentage error was previous iteration just 10%. It will reduce. This is not the exactly concept. But we have to always we have to check the limit that we have. Most of the cases we find this, but this is not mandatory that we will always get the less percentage of error.
স্যার তাহলে স্যার ডাইভার্জেন্স যাবে না স্যার?
No, we cannot just from one iteration or two iteration we cannot. If this is now the percentage is 110%, say, if again is go high, then we can say this is diverging. Still we are not sure that is diverging or converging. We have to go for next iteration and next group. Mostly I checked total it needs 4 iterations. That means we did 2, another 2, we have to go, and then you will get the target results. If I am sharing, I just open here. So if we check this problem, the iterate to a level of epsilon s equal to 1%. That means our percentage of error should be less than 1% or 1%. So of course it will converge with 3 or 4 iterations. Otherwise we cannot summarize. Another factor is we are solving this problem, we can say by hand, but nowadays or in practical case we will not go or we will not solve by hand. Mostly we have to use the computer program for this. So in that case 3, 4 or 5 iteration is very less to solve the problem. Even we can go for very high value of iteration, so it will be converged. So for our example of 2, 3 iteration, we cannot decide whether it is converging or diverging. Any other question, please? So in online class, the problem is mostly student cannot concentrate. If you can concentrate, then it's okay. Otherwise, can you see this? No, most probably no. Okay, I am going to our previous places. So Baristo method. This is the key values of this method. If you can apply this recurrence relationship, I think very easy to go ahead. just you can see the relationship between BAB and BC. So BN equal to AN equal to CN, we can say. BN minus 1 equal to AN minus 1 plus RBN. Cn minus 1 equal to Bn minus 1 plus RCN. Both the same. So if we can apply this recurrence relationship, we can finish this problem very easily. If you apply, then we can compare with other method how it is converging for the speed of convergence, how many iterations are required, how long the calculations are. We can say. So this is again, if you have any question about Barristo method. How many we have in this class? Can say.
স্যার এই পিডিএফটা কি শেয়ার দেওয়া যাবে এই যে এই ওয়ার্ড ফাইলের
একটু বলো।
স্যার এই ওয়ার্ড ফাইলের পিডিএফটা কি শেয়ার দেওয়া যাবে
হ্যাঁ, দেওয়া যাবে না কেন? দেওয়া যাবে। এটা দিয়ে দিব। In previous class we studied. Again we are studying here to solve the problem. We have to have this to solve this problem. So any question, how many we have? I just stopping the share. Chat box. Oh, if you don't have any question from my side again, where is the
স্যার আমরা তো আজকে দুইটা ম্যাথই দেখলাম যে ফ্রম চাপরা স্যার বুক আর হচ্ছে আপনার এই ওয়ার্ড ফাইলের এটা জাস্ট টু স্যার মেক শিওর
So you can also check the book
ওকে
Shastri,
ওকে
but the one thing you have to remember, they use style is same, of course, all are same, but they use the another notation. Notation means here we are using A, B or C, but they change the notation relationship. The concept are of course same. So now my point is again, mostly in mid examination, to found that we are using some electrical circuits or electrical engineering related terms for applying our techniques. So if again if we have RLC circuit, say if you find this is I, this is B. If this current is a function of B, then you have to find out the value of B by using like this, given the current is, current I equal to like V4 or V, if I remember VI pi to the power of power 4 plus, sorry, 4, I cannot write, 3 pi square, pi cube plus 5 vi square. Like this equation, you have to apply the Barrister method to find the root of input voltage Vi. So both are same. The problem already I observed, you are considering the x equal to Vi. It's okay. After taking x equal to Vi, you are solving, you are concluding the value of x. But the question is not asking the value of x. Question is asking you to find the value of Vi. So after getting the value of x, of course, you should again convert the value of x to Vi. You should say Vi, if x is 1, Vi will be 1. But you have to say. Otherwise, the answer is not correct, because your question is asking you to find the value of Vi, but you are presenting the value of x. This is actually is not correct. The examiner, if examiner is not your direct teacher, class teacher, then he'll be confused. So please remember this and try to apply same equation by considering the other quantities like Vi, Ii, or power, or some electrical quantities. So this is after checking the script, this is my recommendation. But some students already corrected this. He took the value of x with Vi or Ii. After, at last, they again converted this value. This so it's correct. Please consider this. Remember this. We don't have any other because in one class, if we can go for another techniques, it's better. The next class we'll again go. We'll check the technique Gauss elimination method. Next class we'll study Gauss elimination method. So up to this today's class, so I will take the attendance. Please response as like you responded in your class. Give me a few minutes. On section A, 101.
Present, sir.
Go.
Yes, sir.
102.
Yes, sir.
103. 104. 105.
Yes, sir. Yes, sir. 3, sir.
107.
Yes, sir.
8. Abdullah Al Jayed. 9.
Present, sir.
Jubair.
Present, sir.
10.
স্যার 108 এর মাইকের সমস্যা
Okay, no problem.
স্যার অ্যাটেন্ডেন্স
11.
Yes, sir.
13. Tahsin Jawad.
Yes, sir.
14,
Yes, sir.
15,
স্যার 108 স্যার। স্যার মাইক্রোফোনে একটু
হ্যাঁ।
সমস্যা ছিল।
108, I got it here.
স্যার 103 ও।
হ্যাঁ, already. 15, 16,
Yes, sir.
17,
Yes sir.
18, 20,
Yes sir.
22, okay, 22,